Okay, let's walk through the steps of finding this limit as x approaches 10 for this third degree polynomial divided by first degree x minus 10. So the very first thing we always want to do when we're starting with limits approaching numbers is you want to replace each one of the variables with whatever value it's approaching. So in our case, that's going to look like 10 to the third power minus 8 times 10 squared minus 17 times 10 minus 30. And for our denominator, 10 minus 10. And then we'll go ahead and evaluate this, figure out what this equals. Well, the denominator, that one's pretty easy. It's going to equal 0. But for our numerator, it looks like we have 1,000 minus 8 times 100 will be 800 minus 17 times 10, 170 minus 30. Well, it turns out our numerator also equals 0. Not a big deal. That just tells us we need to continue on, keep going with this process. It also tells us another important piece of information. All right, it tells us as we're looking at this limit as x approaches 10, because our numerator and denominator each equaled 0 when we evaluated it at 10, that's telling us that x minus 10 is a factor for both our denominator and our numerator. All right, so our end goal here is really, we have to find that other factor for our numerator. Then when you multiply by x minus 10, it gives you that third degree polynomial we started with. All right, to do so, we could do long division, or we have this other synthetic division, which can speed up this process. So let's go ahead and set up synthetic division and talk about all the steps for this. So basically, as you set up your synthetic division, because x minus 10 is going to be a factor, we can put positive 10 out in front here. Then what we do is we copy down each one of the coefficients for each term from that x cubed minus 8x squared minus 17x minus 30. So it's 1x cubed, going to go up here, negative 8x squared, negative 17x, and negative 30. You'll notice I do this. I'm just being careful that we didn't skip over any powers of x. We had x to the third, x to the second, x to the first, and then x to the 0 or a constant. So if we were to have skipped over a power of x, we'd need to include a 0 as a placeholder for that, that term that was missing. All right, so now jumping into this process. The first thing we do is we go ahead and bring this first digit, the 1, down. Next, we're going to always multiply, then add. We always multiply by that 10, in our case, that's out in front. So 10 times the 1 at the bottom is going to make 10. And then we add. We always add vertically. So negative 8 plus 10 is going to make positive 2. We're back to multiplying. So 10 times 2 makes positive 20. Next, we add again. So negative 17 plus 20 is going to make positive 3. Back to multiplying. 10 times 3 makes positive 30. Finally, as we add these together, we're going to get 0 at the end. All right, that's actually what we're looking for, is to always get 0 at the end. If we don't, then something's gone wrong along the way. And why that is because the 0 at the end is going to be the remainder for our division. Reading the rest of this, the quotient for our division is going to be represented by these numbers, the 1, 2, and 3. All right, it always works that it's one degree less than the original starting x to the third. So it'll be 1x to the second power plus 2x to the first power plus 3 as a constant is going to be our quotient. So basically, that can fill in right up here because we divided by x minus 10. X squared plus 2x plus 3 can get filled in up here. And now what we're going to do is we're going to go ahead and simplify this down to lowest terms. We're allowed to cancel out the x minus 10 from the numerator and the denominator because we're taking a limit in this case. So we'll go ahead and bring along our limit as x approaches 10, and all that remains is going to be the x squared plus 2x, sorry, I put it in parentheses, plus 3. Doesn't need to be in parentheses. All right, and then we go ahead and evaluate by replacing each of the x's with 10s. So we have 10 to the second power plus 2 times 10 plus 3. It's going to work out to be 100 plus 20 plus 3, which should end up giving us 123 for our limit. So that's going to be the limit. If it's been a while since you've done synthetic division, it's a really handy thing to know about because it can make factoring these third-degree polynomials much, much easier, especially if you already evaluated at the beginning and you kind of know what one of your factors is going to be, or a value of x that makes the entire numerator equal 0. It makes our life a lot easier factoring third-degree polynomials than just trying to do it using doing it by hand or in your head. I highly suggest getting comfortable with synthetic division because it can be really, really helpful when you're trying to do some factoring, especially higher degree polynomials. So I hope this helps out. Good luck as you're working on limits.